All right, so we want to go ahead and find h of x, and h of x is going to equal f of g of x. Remember the notation, I can either write it this way or f of g of x. All right, so either way, what this means is that my inside function is g of x. So I take my g of x, and it's going to end up going inside and replacing x inside the function. Now, we're going to talk about domain first because domain is really important. For g of x, x cannot equal 0. And for f of x cannot equal -4. Now, notice what we're talking about here. G of x is going inside f of x, and this is saying x cannot equal -4. So if x cannot equal -4, over here, that also means that 1 over x cannot equal -4. So to solve this, let's just go ahead and cross the multiply, and I get -4x cannot equal 1, or x cannot equal -1/4. So the domain of this function starting out with has these 4 parameters. X cannot equal 4. And we started off with g of x could not equal 0, and that's because the denominator could not equal 0. And then whatever this value is here cannot go in and be -4. And that would happen if I started off with x is equal to 1/4. If x was equal to 1/4, I would put it into the function, and that would give me, oops, dropped my negative sign there, guys. Sorry about that. So if I started off with x was equal to -1/4, and I put it into this function, that would give me the reciprocal of that, which would be -4, which is not allowed to go inside this function. All right, so now that the domain of f of g of x has been handled, we know that the domain here for h of x can be everything but x cannot equal -4, x cannot equal 0, and x cannot equal -1/4. So let's go ahead and find out what h of x equals. H of x starts off as f of x, which is 5 over x plus 4. Then I take my entire composition function, which is 1 over x. I take that comes down here and gets replaced for x. Now I have f of x is equal to 5 over 1 over x plus 4. Now I want to go ahead and simplify this. I'm going to go ahead and simplify this by multiplying the numerator and the denominator by the common denominator. Again, x over x is just equal to 1. And when I do that, I can simplify this complex fraction and leave that as 5 over x. Now what I'm doing here is I'm taking all of this and multiplying it times x. That is 1 over x times x plus 4 over x. Those x's cancel and become 1. And now we are just left with 5x all over 1 plus 4 over x. Now, hopefully you'll see that matches back with what we said in before with our domain. Let's look at what I have here. So the domain, when you're doing the domain of this, you have to watch out. It's always the domain of f of x. Any excluded values must be excluded at the end. The excluded values from g of x also must be excluded at the end, as well as looking at the final product, and you can see that 1 plus 4 over x cannot equal 0, which means 4x cannot equal negative 1, and x could not equal that negative 1/4. So that's where that negative 1/4 again comes from. All right, so we have another one here. So let's go ahead and start with the domain of f of x. The domain of f of x, anything underneath the radical must be greater than or equal to 0. And the domain for g of x is all real numbers. Now, when I'm setting this up, I want to go ahead, in this case again, I want to find f of g of x. Now, what does this mean? It means g of x is going into f of x. And in order for g of x to go into f of x, what does this mean here? It means whatever goes into f of x must be greater than 0. So set this up. You know that x minus 2 must be greater than or equal to 0. So x must be greater than or equal to 2. So how does this work? I take that g of x and start by finding this out. My original function, f of x, is equal to the square root of x. But I want to find f of g of x. So everything that I'm taking here, my x plus 2, comes down and gets put inside my function. So this is equal to the square root of x minus 2, which again matches what we set up here. So the domain of my composite function is both of these, and the stronger of the two statements, x must be greater than 2, includes the fact that the domain for f of x had to be greater than or equal to 0.